Okay, so we're going to look at question 8. It says, the demon drop at Cedar Point in Ohio takes riders to the top of a tower and drops them 60 feet. A function that approximates this ride is h of t equals negative t squared plus 64t plus 60, where h is the height in feet and t is the time in seconds. So, quadratic word problems are pretty awesome. We're just going to go ahead and we're going to take this quadratic function that they give us, and we are going to go ahead and type that into Desmos. Okay, so I went ahead and I typed it into Desmos, and this is what it looks like. So before we really look at like what the questions are, let's go ahead and like break down what it means. Well, the first thing is that I had to zoom out. I had to zoom out to be able to see my entire graph. So when I clicked my graph, 4 points came up. When we're talking about a word problem, do you see how this one here, this point down here, has a negative x value? When we're talking about word problems, we're talking about all positive things. Positive time, positive height. So this point here that has a negative x value is not something that we're going to be using. All right, so that leaves us with the remaining 3 points. Well, this one here, that is my y-intercept. And the reason why I know that is because my x value is 0 and my y value has a number. So this point here is my y-intercept. In a word problem, this y-intercept is my starting amount or my initial value. So this is like where for in this case, where the drop is happening. It's happening at 60 feet. So that is the start. Okay. Now, the next thing that we have is we have our maximum. This is the top point of our quadratic. So if you notice, we have a x value of 2 and a y value of 124. When we're talking about word problems, our x value is our time, which means this is 2 seconds in this case, and h is my height of 124 feet. And then we go all the way down here, and this is my x-intercept. This is where we're talking about like our ground level. Or like sometimes it's not the ground, sometimes it'll say like it's the lake. But same thing, our x value is our time and our y value is our height, which it makes sense that this has a height of 0 feet because it's my ground. Okay, so let's go ahead and let's figure out what the questions are. The first question says, what is the rider's initial height at the top of the tower? Well, we talked about initial height. Our initial height is also what's called our starting amount. So I'm actually going to add that here. Initial height. So I'm going to say my initial. So my initial height for this one is at 60 because that's what my y value, my y-intercept is. So that would be 60. Okay, now let's look at question number 2. Question number 2 says, well, how many seconds are the riders on the ride when they reach 108 feet? Okay, so 108 feet, that is something that is new. We didn't have that in our graph. I'm going to come back to that one. Let's look at C. C says, how long does it take the riders to reach the ground? Well, if I look at my Desmos, we said that our ground is down here. Okay, it's this point here. Well, it says how long does it take, meaning we need our x value at the ground. Well, the x value is 4.784 seconds. Which really, we're just looking for that number. And then the next question is, what is the height? What is the highest point on the ride? Well, we know our highest point is up here at our maximum, and we're looking for our y value. So our y value here is 124. So our highest point is 124 feet. Okay, so now we need to go back to our Desmos because we have to figure out question B. Question B asks us how many seconds are riders on the ride when they reach 108 feet. So 108 feet, that is a height value. So we're going to go to Desmos and we're going to type in Desmos y equals, because remember, x is our time, y is our height. And we're going to type in y equals 108. Okay, so I went in line 2 and I typed in y equals 108. And then when you look at your graph, this blue line cuts across the y-axis, and there were 3 points that showed up. So we need to actually talk about this for a second because this is important. So when we're asking how many seconds are the riders on the ride when they reach 108 seconds, this point here, 0, -8, that is not even on my red graph. That is talking about where y touches 108. So that is a point that we're not going to use. We need to look at the graph where where that blue line, 108, is touching my quadratic, which is at this point. Here, let me change that color. This point here and this point here. So this point is 3, 108, and this second point is 1 and 108. So when we talk about how much time, we're talking about our x value. Our x value is the time, and these are both at a height of 108. So for this question, when it says how many seconds are the riders on the ride when they reach 108 feet, you could answer 1 second, or you could answer 3 seconds. Both are possible answers because those are the 2 points that are on our quadratic at a height of 108 feet. Okay, the last and final thing is it might ask, how long does it take to get from the highest point to the ground? So here I drew a little picture. I got our highest point up here and our ground down here. Okay, and if it's asking how long does it take, we have to look for the x value for both of them. So we would take the time at the ground, which is 4.784, and we would subtract from the amount of time at the top, which is 2. So the answer would be, it would take 2.784 seconds, because I would subtract the time at the ground from the time at the height. Okay, so let's go ahead and practice question number 1. Go ahead and read the question, type this equation into Desmos, and answer the following questions. Okay, and then let's go ahead and look at question number 2. Go ahead and read the problem, type in the function equation that it gives you, and go ahead and answer the questions.